Lesson 4-4, Arithmetic Sequences. A sequence is an ordered set of elements that follows a pattern. An arithmetic sequence is just a sequence that shows the y values increase or decrease at the same rate. Then we also have infinite and finite sequences. An infinite sequence has unlimited elements, and a finite sequence has limited elements in the sequence. Now, for an arithmetic sequence, you do have a common difference. And the common difference is the number added or subtracted from one term to the next. And when I say subtracted, it means you're really adding a negative number. So the formula for an arithmetic sequence would be a subscript n equaling a subscript 1, which the 1 means the first term, plus n minus 1 times d. The n means the number of term that you're finding. The d is the common difference. So in this video, we're going to review how you can find the rule of an arithmetic sequence and be able to complete a arithmetic sequence, and also to find a specific term of the sequence. So our first problem, we want to determine if the sequence is an arithmetic sequence, and if so, what is the next term? So to find the common difference, just take the second term minus the previous term. So 3 minus 2 is 1, 5 minus 3 is 2, 8 minus 5 is 3. So no, this is not an arithmetic sequence because they're not adding the same number each time. Next goes from 42 to 19 to -5 to -27. If I did 19 minus 42, 19 minus 42 gives us -23. And -4 minus 19 also gives me -23. -27 minus a -4 is also a -23. So yes, this is a arithmetic sequence. And if I subtract a -23 from that, -27 minus 23 would give us a -50. So the next term would be a -50. Next one, you have 2 to -5 to -7 to -19. Here you're subtracting 7 every time. So if we're subtracting 7 every time, this would be an arithmetic sequence. So yes. And the next term would be a -26. Here we got 1, 2, 4, and 7. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 3 is 7. So no, there's not a common difference. That means there's not an arithmetic sequence. This next one, I have t plus 8, and 3t plus 5, and then 5t plus 2, 7t minus 1. So if you look at this next one here, you look at the t's, they're increasing by 2 every time. And then if you look at the constant, the integer at the end, they're decreasing by 3. So yes, this is a arithmetic sequence. The next one would be 7t plus 2 would give us 9t. And then if I'm subtracting 3 each time, this would be a -4. Next, 0.1, 0.01, 0.001, 0.0001. This one is actually a geometric sequence because you're multiplying by 10 every time. So for it to be an arithmetic sequence, you have to be adding the same number each time. Next, here we have some fractions. I go from 1/2 to 3/2 to 5/2 to 7/2. 1/2 plus 2/2 is 3/2. 3/2 plus 2/2 is 5/2. And 5/2 plus 2/2 is 7/2. So the common difference is 2/2. So yes, this is an arithmetic sequence. The next term would be 9/2. Next, I have 1/2 plus, or 1/2, 1/3, 1/4, 1/5. So in order to get to 1/3, I would have to have common denominators here. So 1/3 minus 1/2 would be common denominator is 6. So this is 2/6 minus 3/6, but that would give you a negative 1/6, which is not, and if I were to take a 1/2 or 3/6 minus 1/6 would give us 1/3. So right now this gives us a negative 1/6. Now if I did 1/4 minus 1/3, common denominator would be 12. So I would have 3/12 minus 4/12, and that gives us a negative 1/12. They're not the same. Negative 1/6 is not the same as negative 1/12, so no, that's not an arithmetic sequence. Moving on to our next one, here we want to find a specific term. So here we want to find the 16th term using the formula given, and they tell us what the sequence is. So for this one, we need to put the number in. The first term is 1, so n is 16. So wherever you see an n, we're going to put 16. So I need to find the 16th term. When the first term is 1 plus 16 minus 1, and the common difference to go from 1 to 2/3 to 2/3 to 1/3, it would be a negative 1/3. So now I'm just going to grab my calculator here. So we have 1 plus, and then in parentheses I have 15 times a negative 1/3. That's going to give us a negative 4. So our next term, the 16th term, would be a negative 4. Next, we need to find the 13th term of the sequence using the formula. So I have a subscript 13 equals the first term of 7 plus 13 minus 1 is 12. And then it's decreasing by 3. So 12 times negative 3 is negative 36. And we have negative 36 plus 7. Negative 36 plus 7 is going to give us negative 29. So the 13th term would give us a negative 29. Then we have to find the 20th term of the sequence. And the first term is negative 19 plus the 20th term minus 1, so 19 times the common difference, and the common difference would be 4. So that's 19 times 4 is 76, minus 19 gives us 57. So the 20th term of this sequence would be 57. Moving on to our next part. Here we want to find the 100th term of this sequence. So the 100th term, the first term is 0.25 plus the 100th term minus 1 times the common difference. And the common difference, if I did 0.5 minus 0.25, that gives me 0.25. So this would be increasing by 0.25. So we have 99 times 0.25. And then we're going to be adding 0.25 to that. And that gives us 25. So the 100th term of this sequence would be 25. Sample problem C. Here we're going to write the function rule for the nth term of the arithmetic sequence. So for here we have so we're going to have our equation written in the same format of the equation that we had here. So a subscript n equals the first term plus n minus 1 times the common difference. So we need to find the nth term The first term is negative 50 plus n minus 1, and the common difference go from negative 50 to negative 25 is a positive 25. So our function rule would be a subscript n equals negative 50 plus n minus 1 times 25. But if I also want to write it so I put it in like the linear function format, I would have to distribute the 25 in here, and that would give us a subscript n equals negative 50 plus 25n minus 25, which this would give us a linear function of a subscript n equals 25n minus 75. So either one, this one, or this other one would be acceptable for your rule. Next, write the function rule for the nth term of this arithmetic sequence. So here we can see we're adding 2 each time, so the common difference is 2. So I would have a subscript n equaling 2 plus n minus 1 times 2. If I were to distribute, this would be 2 plus 2n minus 2, which will make this a subscript n equaling 2n plus 0, which I wouldn't need to do that. So just 2n. A couple other ones. Here we need to write the function. Here we're adding 3, so the common difference is 3. So I'd have a subscript n equals the first term of 4 plus n minus 1 times the common difference of 3. If I were to distribute, I would now have a subscript n equaling 4 plus 3n minus 3, which makes the equation, or the function rule, a subscript n equaling 3n plus 1. And then this last one here we're adding 5 each time, so a subscript n equaling 3 plus n minus 1 times 5. If I distribute, I now have a subscript n equaling 3 plus 5n minus 5, which will now make the rule a subscript n equaling 5n minus 2. And our last problem. Mr. and Mrs. Tompkins started a college fund for their son Marcus when he was in the first grade. They began the fund with $2,500, and each year they increased their contribution to the fund by $500. What was their contribution to the fund when Marcus was a senior in high school? So if we use the formula, we need to find the 12th term, because senior year is your 12th year, and if you're starting the first grade, equaling the first term, they start off with $2,500 plus the nth, so that's 12 minus 1 times each year they're putting $500 in. So that's 2,500 plus 11 times 500 gives us 12th year, there would be $8,000 in the account. So that is our lesson on arithmetic sequences.